Let's review the element card activity that we did in class. So you might remember that you were given a series of element cards that looked like these, and that your task was to arrange them based on their similarities and patterns. And we started with this series of yellow cards where we had this beryllium on top and all the way down to strontium. And we recognized that what these four cards had in common was that they had the same color of yellow, that they had two different pegs sticking out from the side of them. We also recognized that they were always found with two chlorines, so BeCl2, MgCl2, CaCl2, and SrCl2. So those are chemical properties that seems like they always react with two chlorines. We also recognize that their actual appearance, the physical properties we call those, were similar in that they were silvery, they may have been shiny, all of them were metals. And in this corner, we looked at, again, another chemical property of how they actually responded to water. So with a slightly reactive going all the way to very vigorously reactive. We also noticed in pattern-wise that we have these numbers below these chemical symbols that got increasingly larger, and also the size of them got increasingly larger. So based on those similarities, we then place the other chemical or element cards into similar groups. So you'll notice here all of the elements have just one peg sticking out of them. They are the same color. The size goes from smaller to larger. That's the case for these numbers as well. On this side, same story. You'll notice that in terms of how they react, that they're all non-reactive, including this one. This one looks like it only has two pegs, but it's one of those that actually has the same sort of chemical properties in that it's non-reactive, and it also has that red color. And you'll notice that in this one here, it always reacts with one fluorine. So we group these these elements together based on similar physical and chemical properties. Now, as you go across, you were organizing these across, and you recognize that there is the pattern that we have starting with one peg, an element with one peg, to two pegs, to three pegs. And as you go across, not only are the pegs increasing one at a time, but these numbers right below here are increasing as well. So they progressively get larger, these values, until at one point we are starting at around 7 going to about 20. You'll also notice that the size gets smaller and smaller. And that's the case for this row as well, is that they get smaller and smaller as well. Other than that, you won't find too many similarities other than the fact that their pegs get increasingly larger, their size gets smaller, and these numbers get larger. So what scientists really did was they actually found these elements that they had found in the earth and so forth, and they looked at these elements and looked at their physical and chemical properties. Remember, physical properties are properties that can be observed, and chemical properties are ones that can actually it looks at how they respond to different chemicals. And what they did was they organized all the elements that had similar properties and put them into these groups. All right. Then from that point on, they sort of looked at the masses and then organized them in what we call rows. So and with that said, they then were able to develop the periodic table. And if we look at the periodic table, there we go, you'll notice that those cards now are more or less organized in exactly the same way, but in this case, we have a little bit less information, a little bit less of a visual. And so what I'd like to do for the next few minutes is really break down the periodic table. So just as a reminder, remember that as we move down the periodic table over here, these chemicals have similar properties. They all have one peg. They get increasingly larger as you go down, and as you notice, these numbers get increasingly larger as well. Those were the numbers that we saw in the center of the circle. Then at this point across over here, you're going to notice that here, same story, we have the numbers getting increasingly larger. Just a reminder, this was those yellow circle. That means that those yellow circle, the size of the atom is getting increasingly larger. And in this case, it has 2 pegs. So now where is it that you can see these numbers of pegs? And I'll just kind of mention it right over here. Do you notice that right here we have 1A? That tells you at this point number of pegs. And for those of you who have seen this already, we're going to call these the number of valence electrons. And we're going to go into deeper detail of what that means. I just want to introduce that idea. Here we have the 2 pegs. We had boron next. There were the 3 pegs, 4 pegs, 5 pegs, 6 pegs, 7 pegs, and 8 pegs. Don't worry about these here. These are unique and we'll be talking about those later on. So just a reminder, as you go down the periodic table, just remember the size gets larger. So we have the size increase of those atoms. And also just a reminder is as you go across the periodic table, remember from before, the size gets smaller. So see how the size gets smaller. So the size of the atom, and again, I'm going to discuss that in more detail, decreases. Okay, a couple of other things we talked about was that they're going to behave in a similar way with different chemicals. So as we go down on this side, they become more reactive. And for this one right over here, we're going to start right there. On this side right over here, and we're going to ignore these right here, these become more reactive the higher you go up. So it's doing a reverse type of reaction. So more reactive on the top versus the bottom. Okay. All right. What are some other things that we want to talk about? We want to talk about that these all tend to have a silvery sort of appearance. And if you can just make a note of this little staircase that's right over here, and on your periodic table, if you can note that, we'll just say everything to the left of this, we consider a metal. All right, so these are the metals all along here, and everything to the right of that staircase is a non-metal. All right, and metals tend to have more a silvery appearance. They tend to conduct electricity, so they behave in a similar way, and you can always find that based on this staircase. Now, as I mentioned earlier, each of these groups, and let me define what a group is. Anything that is a column, this is called a group, okay? So what's going down, this whole thing right over here is considered a group, okay? So we have a group here, a group here, a group here, and anything going across is considered a row. All right, so let's go ahead and add that in our vocabulary. So to add some more detail to that. I'm going to go ahead and erase this just because I want to identify some of the more important groups. This group right over here has a special name because it is very reactive, and it's has a tendency to be seen in a lot of chemical reactions. So this group, and we know it's a group because of this column, is called the alkali metals. Okay, and just as a reminder, the alkali metals, remember, looking back at this right here, they all have one peg. They tend to become more and more reactive with water as you go down. And so that makes them relatively unique. Okay, this next group over here has a similar name, but they behave quite differently. This group right over here is called the alkali earth metals. All right, and again, they're also an important group because we actually see them quite a bit in chemical reactions. There are only two other groups that I want to focus on, and that is this group over here, which also has a tendency to be quite reactive. And this group over here, just a reminder, has 7 pegs sticking out of it. There are those 7 pegs. That's this group right over here. And they are called the halogens. Okay? And we know that they get increasingly more reactive as they are at the top. And then finally, the last group that I want to discuss is this group right over here. These, remember, were the ones that have 8 pegs sticking out of them. There we go. And these right here are non-reactive. So just a reminder of what that one looks like. That's this one right over here. These are non-reactive, and they are called the noble gases. Okay? So we have one other region that I just want to introduce. It's literally more of a, for lack of better words, a landscape. And that is this group right over here. Let's do yellow. And this group right over here is kind of all clumped together because they have these sort of unique characteristics. And I'm going to actually include these all the way down to about here. This whole region right over here, they just lump together in something that is called transition metals. Okay, so those are transition metals, and that's this region right over here. Okay, we'll be talking about those also. Below here are the lanthanides and actinides. We will rarely ever use them, and so there's no reason to really spend too much time on them. So based on what I've drawn here, if you could please include that on your periodic table, including how things react and their different sizes, where the metals and nonmetals are, and the names of the different groups, and so forth.